In this video, I'm going to take a look at some of the big gotchas around mappings. We can consider mappings to be like JavaScript objects, but they are different in some very specific ways. Let's take a look at a normal JavaScript object and what we can do with it. So right now I have this Zoom tool that I use to record my videos. There we go, and there was a space bar just blocking my tab. Okay. So let's take a look at this normal JavaScript object. Inside this editor, I can add some code on the left-hand side, and if it produces output, I can see it on the right-hand side here. And I would see it, like for example, let's try this string. I'll call it howdy. Okay, and we can see it here on the right-hand side, printed out. Now I can paste this string if I copy and paste it. 1, 2, 3, you can see it multiple times on the right-hand side. So I'm going to use this editor for some very common operations that I can use with JavaScript objects. Now, inside of here, let me get rid of this. Inside of here, I already have an object, and it lists out English to Spanish words. The key are colors in English, and on the right-hand side are the equivalent words in Spanish. So red is rojo, blue is azul, and green is verde. Now with a JavaScript object, I can use a couple of different methods to manipulate this object. In particular, I can use the method of object.keys like so. So object.keys, say Spanish colors, okay, and it prints out red, blue, green on the right. And so basically I get back an array of all the different keys that my object has. Now, likewise, I can write it this way, object.values, and I get back the array of values. So another way I can manipulate a JavaScript object is to say Spanish colors and then use bracket notation to access particular keys inside of there. So I could do something like this. Let's say I want to access the key. And so by using bracket notation to access the key of red, I get back its value of rojo. All right. So one other thing, if I try to access a key that does not exist, I'll get the value of undefined. So let's say just do mumbo jumbo. So I get back undefined, which in this code editor, it prints as nothing. So how can I verify that I actually got back undefined? Well, we can say Spanish color index of mumbo jumbo is equals to true. Equals to undefined, not true. And I get back true. So I was thinking of true because I knew that I was going to expect to get true back, because this code editor is indeed printing this out as undefined. It just doesn't print anything. It won't print the actual term under keyword undefined. But if you do equals mumbo jumbo equals Spanish colors with index of mumbo jumbo equals undefined, you get back true. All right. So clearly this returns undefined. So I just walked through 4 simple operations. We can return all the keys that a JavaScript object has. We can retrieve all its values. We can retrieve a single key with bracket notation. And if we try to access a key that is not defined, we get back a value of undefined. So let's now go take a look at mappings with Solidity and get a better understanding of how it works. So I'm going to lay out a couple of big gotchas with mappings. And I want you to understand with these gotchas is that they're going to be in stark comparison to how JavaScript, or stark contrast to how JavaScript objects work. So keys are not stored with mappings, okay? That might seem strange. In JavaScript, we can do like what I was doing. Let's bring that back. So at object.keys, it retrieves all the keys, right? But the same is not true with mappings. With mappings, we're working with a classic data structure called a hash table. The hash table uses something called a lookup process. On the right-hand side, you can see the underlying data structure that represents our mapping, in this case with the values of rojo, azul, and verde. In order to look up some different values from this mapping, we have to provide a key ahead of time. We provide this key, it gets passed to a hashing function, okay? And the hashing function outputs some predetermined index. In this case, maybe index 3. When we get this index of 3, Solidity knows to go to index 3 inside the mapping and retrieve the element of verde. In a Solidity mapping, keys are not stored. That means we cannot get a list of keys, we cannot access them, we don't know what keys a mapping has. So if I start to define a mapping inside of Solidity that looks like this JavaScript object here, we cannot know after the fact whether or not red, blue, green are defined keys unless we try to access those values. So this may sound strange, but as soon as I start to write the code inside my contract, we're going to see why this is relevant and why it makes sense. The next thing about mappings is that values are not iterable. In other words, we cannot loop through a mapping and print out all the variables that it has. If we have a mapping, we cannot write a for loop that iterates through all the values. We cannot run any type of function or call that says, hey, go into the mapping and retrieve all the values that exist. So back inside the JavaScript world, we can do that with object.values, right? So we can do that with object.values, but we do not have that functionality inside of Solidity. All we can do is a lookup, okay? This lookup process. So these mappings are only good for single value lookups. They're not good for storing information that we want to iterate through at some point in the future. With Solidity mappings, it is said that all values exist. Whereas with JavaScript objects, if a key has not been defined and we try to access it, we get back undefined. The same is not true of mappings. In other words, if I look up a key, instead of telling us there's no value at that particular index, we actually get returned some default value for that element. If they are strings, then the default value is empty string. In the JavaScript world, that means that if I tried to look up a key that did not exist, I would not get back undefined, but instead an empty string. The default value we get back depends on the value type of the values inside of our mapping. If these were not strings, but say integers, then we get back a 0 value for an integer, which would literally be the number 0. So this makes it challenging to decide whether or not a value exists inside of a mapping. If you're storing numbers inside of a mapping as values and you want to find a value for a certain key and you look up a string and you get back the number 0, that makes it challenging to understand if that value already exists inside the mapping and it was set to 0, or no, we just got back 0 because that is a default value based on integers. So it's tough to decide whether or not a value exists ahead of time with mappings. Because mappings has the benefit of constant time lookup, and we want to ensure our contract can be used with many different contributors, I will do a refactor, and instead of using approvers, like what you see here, being an array, I'm going to say it's a mapping where the keys are addresses and the values are booleans, and we will know someone has donated to the campaign by looking up their address. And if it returns true, then we know the person belongs. A similar thing inside of the request struct, I'm going to add an approvers mapping that tracks who has voted on a particular, who has voted on a particular request, and to track whether it's a yes or no vote. And I'll have a separate counter that counts the number of people who said yes. Now the counter may be surprising, the separate counter, but remember when working with a mapping, we cannot iterate through a mapping. So I can't store whether someone voted yes or no because I can't iterate through it. So I have to keep a separate counter around to track whether someone voted yes or no. So there's still a lot to learn about mapping. So in a subsequent video, I'm going to start to implement this mapping.